Hello and welcome back to another Civil Exam review. This time we're going to do a review on static. Go ahead and take a look at the specification by the NCEES. If you go into 4, which is a static, it says about 8 to 12 questions. You really want to get all of these because it's not that hard. And they are from A to G, which is, we're going to go ahead and do all of them. Resultant force, equivalent force, rigid body, frame, we already did trusses, centroid of area, moment inertia, and static friction. We're going to do a bunch of problems on each one of them. All right, let's get to work. First, we have this question, and it says a system of concurrent forces shown. Find the resultant force, and then find the angle made by the resultant force. One of the first things we're going to do, I'm going to go ahead and get a component of each one of them. Let's get the summation of f of x and see what they come out to. And looking at this one, it has a 150-degree angle. Take 90 out, so that means 90 minus 150, this will become 60 degree. Okay, so now we have all that. We're going to go ahead and one by one. This one doesn't have an angle, but it has a direction, pitch, which is kind of easier. We're going to use Pythagorean theorem. We talked about that before in one of our sections. So this is 1 squared plus 2 squared. That's a 4 squared. That becomes square root of 5. And this one already given angle. So I'm going to start off from this one, go around. This is a 200. Remember, the component, x component of this is going to be this way. That's going to be the x component, and this will be the y component of that. So the x component is going to be 200 Newton, and that's going to be time cosine 60. Cosine is going to close the gap, so it's going to be like that. This one is going to be going in the same direction, so if we say this going is positive, this actually become negative number, so it's this one minus, and this is going to be 100 cosine 60 also. Then we have this one. It doesn't have a cosine, it has a direction. It's a 500, so it's going the other way. So plus direction, plus 500. And the x component of it, it's going to be, marker is dying. X component of it's going to be right here. X is 2, so divided by square root of 5. Time 2 divided by square root of 5. And that's come out to be 297.21 Newton. Now let's going to go ahead and do the y, summation f of y. And if we say up is positive for now, and we're going to come on, this is going to be negative. It's going to be minus 200 times sine 60. If we use cosine, the up is going to be sine, right? Same with here. That's going to go up, so it's going to be plus 100 sine 60. And this one is going to be minus coming down. It's going to be 500. The y direction is going to be 1 divided by hypotenuse, which is 1 divided by square root of 5. And that comes minus 310.2. Now, they want to know what the direction is. The direction is not that bad. It's going to be, so we're going to go ahead and draw it. So this is a 297 going right here. 297.21. And it's also going down this way at 310. 310.2. So if I'm going to go ahead and just match it right here, the direction is going to be like this. And that's going to be the resultant force. And this angle we got to find. Let's find the resultant force. So the resultant force, F of R, is square root of basically f of x squared plus f of y squared, which come out f of R, square root of, we have 297.21 squared plus 310.2 squared. And that comes out to 429.6 Newton. Which direction it's going to be? So tangent is equal tangent inverse of, what's the tangent inverse of? It's going to be the opposite divided by adjacent. The opposite is 310.2 divided by adjacent 297.2, and that comes out to 4622. All right, so this is how it's done. Okay, let's do this problem. It's the same as that one, and we're going to do the same thing. Summation f of x is equal to 0. Going to the right is positive. You can see it on the screen. Summation f of x is equal 8 cosine 25. And then next one is going to be plus 12 cosine 30. And the next one is going to be going the other direction, minus 10 cosine 60. And the last one is going to be minus 5 cosine 50. See, there's nothing to it. So that become 9.43 kips going this way. We do the same thing with y direction. And that's equal 8's going up to sine 25 minus 12 sine 30 minus 10 sine 60, and then the last one is going up plus 5 sine 50. That is equal. That's minus 745 kip. I mean, it's going down. All right, so we got one going up. That's going to become 943. This coming down is 745. The resultant force F of R come out to be 943 squared plus 745 squared, and that should give us 12.02. Theta, same way, tangent inverse of opposite divided by adjacent, which is opposite is 745 or 743, I don't know, whatever it is, divided by 943, and that will give us 3824. Okay, so now take a look at the next two problems. You will do that, and please, I want your feedback down at the bottom of the description. I'd love to see your feedback. See what you got for result and anything you have. And any of you that, in the past, my students, when they take a fee exam, sometimes they send me back some of the questions. This was an exam, interesting. So I collect those. If you take an exam or you already take an exam, you remember a couple of those questions, email it to me, and that's my email down below right there. Okay, take a look at this problem. This problem says, okay, you got all these forces. What is the resultant force of all this, and what angle it's going to be in? So assuming, because they all pitch in this way, maybe, I'm just guessing at it, the resultant force might going to be something like this. Okay, let's call this resultant force. And we're going to figure out the angle, and we don't know what the magnitude is, and where is this distance x. Of course, I got to put the other distance in 2, and that distance is, like before, I'm going to go ahead and do summation f of x, see what the f of x comes out to be. I'm going to say going to the right is positive, and I'm going to have 60 cosine, 10 cosine 60. And this is nothing. That's going to be 30. But it's going to go the opposite, minus 30 cosine 75. And then minus 40 cosine 45. then minus 50. That comes out to minus 81 kip. That means it's going this way. Now let's do f of y. And we're going to have, they're all downward anyway, so it's going to be equal minus 10 sine 60 minus 20 minus 30 sine 75 minus 40 sine 45 equal 85.9, and it's going downward. The same thing, it's going to be, I'm not going to do the direction, you know what I'm going to talk about, so I'm going to say, okay, resultant force is going to be equal 81 squared plus 85.9 squared. When you have the negative and you square them, they become positive. That's why I don't put it in here. So the 118.1. And theta is equal tangent inverse of opposite will be 85.9 divided by the x part of it, which is that. And these in your handbook, by the way, comes out to 46.7. So we know this comes out to be 118.1, and this angle, it's going to come out to 46.7. But what is this distance from here? X. So if I take a moment about point, let's call this A, O, they called O, it's called O anyway. If I take a moment about point O of all individual forces, that should come out equal, take a moment this about that. Again, remember, moment is a perpendicular distance between the force and the location you're taking a moment. So we have to give them the horizontal portion of this not going to take a moment about this point because it's in the same line of action. So I only have to give a vertical component of this and find this distance. So I'm going to say, okay, take a moment about point O is equal. It's going to be R, which is 118 times sine 46.7. So that's a vertical component of this force right here, multiplied by X. That should be equal all these individual. I'm going to start from here. This one cannot take a moment. It's on the same line of action. So this one is going to be the vertical part of it. So it's going to become 40 sine 45 multiplied by 5 and 3 is 8, 8 and 4 is 12. And this one is going to be a 30 sine 75 plus 30 sine 75. That's a vertical component of it. Time 3 and 4 is 7. Plus 20 times 4. Okay, so this equal that. Check my number, 622.2, and it's equal 118. This right here. So therefore, X is equal 622.2 divided by the vertical component is, we already know, it become 85.9 anyway. And X comes out to be 724. So this is 7.24. Okay, you do the next one and type your answer below the description while I erase this board. Problem. We got this beam. It says neglect the weight of the beam. And we have a roller here with 1 reaction, pen here with 2 reaction. I think this one is this is a A and that's a B. And I want to find out the reaction force. Well, it's easy to do that. I'm going to take a moment about point A. summation moment about point A is equal to 0. Counterclockwise is positive, the rotation. So I'm going to work from this way. I'm going to go all the way to the other end. First, I'm going to have RBY, and it's going to rotate counterclockwise. So that's a positive rotation. RBY time all this distance, 1.5, 2.5, 2, 6, I think that's 12. Time 12. Then we're going to have this one is going to go counterclockwise, clockwise, so it's going to be negative, minus 90 time 12 minus, this is going to be 10.5. And then we're going to have this one minus 45 time 8. And now here, because I got distributed loaded, I'm going to take this distributed load, replace them with one big force right down the middle. And that's going to be basically 30 times 6, which is 180. And that's going to be basically minus 180 times 3. Because that's going to be down in the center, so that's, if this is 6, that's going to be 3. I believe that's all I got. It's equal to 0. So RBY comes out to 153.8 kilonewton. So I'm going to use summation f of y is equal to 0. I'm going to have this going to become out 153, I said? Yeah, 153.8. 153.8 minus 90 minus 45 minus 180 plus RAY equals 0, and that gives me RAY is equal 161.3. Here's it, nothing to it. Okay, you do the next one while I erase the board. Okay, we're going to continue with the rigid body. This time we're going to do a frame. So we got this frame, and they want to know, calculate all the forces on the each member. It's a crane, basically supporting 10,000 pounds, and then but you have to they give you the weight of each member. The boom is 1,500, the post is 1,400, and then the bracing is about 900 pounds. So let's go ahead and calculate this. First thing we want to do is look at this, at the whole picture before we break them down. And then we want to find out the external reactions, which is these three right here. And what we're going to do is we're going to go ahead and take a moment about, let's take a moment about point A. Counterclockwise is positive. I'm going to have this is going clockwise, so it's going to be 10,000 pounds minus 10,000 pounds time the distance was, that's 4 feet, and 10 feet is 14. So that's 4 feet, 10 feet, that's 14. And then we have the weight of the boom, which is 1,500 pounds. It's down the center of this 14. So that's going to go same direction, minus 1,500, and that's a 7 feet. And then this is not going to take a moment about here. It's the same thing, same line of action. Now 900 is going to be down the, that's going to be 5 feet. So this is going to be right here, 10 feet. So center is going to be 9 feet. Minus 900 times 5 feet. Then we're going to have the BX rotate about counterclockwise on this member here, which is, that's a 2 feet right here. Then we have 10 and 2, so it's 14 feet. Time 14 is equal to 0, so RBX comes out to be 11,071. And that's going this direction, that's a pound. So I'm going to use all the three equilibrium equations. Summation fx is equal to 0. Going right is positive. I have nothing except this one and that one, so that means RBX is equal RAX which is the basically the opposite way, and that's going to come out to be 11,071. So our AX is going this way, that's all. Pound. And I'm going to do summation f of y is equal 0. Going up is positive. I have minus 10,000 minus 1,500 minus 900 minus 1,400 plus RAY equals 0. So RAY comes out to be 13,800 pound. So now we have this, we can easily go ahead and break down each member. I'm not going to do the whole thing, so I'm going to just take one member and analyze it, and you can go ahead and do the rest of them. Let's take this and look at this member. I'm going to take the boom. Let's take the boom apart. I'm going to just write it right here, and there's the boom right here. Okay, bring that boom, and let's put the forces on it. I got 10,000 pound here, and then I have joint D right here. We're going to have dy and dx. And then on top, I'm going to have the weight of the boom itself right here. That's 1,500 pound. And then here at joint C, I'm going to have cy and cx. So they want to know what are these members are. Again, you have only 3 equations to deal with. Summation of x, summation of y, summation of moment. We can use those to our advantage to calculate these. So I'm going to go ahead and take a moment about point C. Counterclockwise is positive. So I'm just going to be a 10,000 minus 10,000, and that distance again was 14 feet. Then come back in here. I have a dy time I think this is a 10 right here. All right. So let me do this. This 1,500 is at 7 feet. It's right here. And that's at 10 feet from there. That's at 4 feet. Got plus dy times 10 minus 1,500 times 7. So dy comes out to be 50 pound. 15,050 pound. Now I can use summation f of y is equal 0. So I have minus 10,000 plus 15,050, and then minus 1,500, then plus cy, minus cy. Cy comes out to be 3550, and it's downward pound. And if I do summation f of x is equal 0, I'm going to have cx equal dx. But I still don't know what they are. That's the problem. That means I have to go analyze another member to find out what cx and dx is. So I'm going to analyze this member right here. So here's the free body diagram for it. I'm going to take advantage of this free body diagram. I'm going to take a moment about point E. Since I'm out of room, I'm going to come over here. summation moment about point E is equal 0. Going counterclockwise is positive, and that's going to be dx. This distance right here is given to us as 10 feet. And this is a 5 feet here, 5 feet here, so that's 10 feet. That's good. So we're going to have dx times 10. And then I'm going to have minus dy also times 10. Then I got minus 900 times 5. So I got that one, I got that one, that's it, equals 0. But we already know what dy is because we calculated right there. So if you plug in all this number, so instead of dy, I'm going to go ahead and put in 15,050. Right here, the 15,050, plug that in. dx I don't know, so therefore I'm going to find dx. So dx comes out to be, same thing, 15,500. Check my calculation, I think that's right. And I'm not going to go ahead and do it. You can go ahead and do summation fx, find the ex either. So now I found this whole number. And this is how it's done. To find the ex, eoy, just do the same thing. Do the summation fy, summation fx. You find the rest of this number. Now I'm going to erase this board, and you go ahead and work on this next problem right there, and then love your feedback. Okay, a lot of people have a hard time with this type of problem. They want to find either area underneath here or the centroid. Let's find the centroid here. And just going to go over it step by step. Once you know how it is done, it's really easy because there may be one or two of these on our exam, and it's an easy point. So don't be scared of it. Don't walk away from it. Just enjoy it and watch the video and see how I do it. So now what we're going to do, we're going to go ahead to find a centroid this. I'm going to go ahead and make a slither right here, element, just tiny bit. And I'm going to say, no, the width of this is a dx. The height of this, we're going to call it y. And if from here to here is x. So now, if you look at the your handbook, they have an equation for these also. So I'm going to say, okay, dA basically is equal to the area of this multiplied by y, which is y times dx, and that's the area. We know that. Now at the centroid, this x bar is basically equal x, and y bar right here is basically the y divided by 2. So I'm going to go ahead and say, okay, x bar is equal x, and y bar is equal y divided by 2, which is this right here. At the same time, they say, okay, y of this curve is equal x squared. Make it easier. Based on a handbook, they said, no, what the center is going to be is equal the integration of x bar dx divided by the area of dA. So I'm going to just go ahead and plug in. Instead of a handbook, you have this equation. Basically, x bar times dA divided by square root, integration of dA. And if I'm just going to go ahead and plug in, we're going to say we're looking from 0 to 1. And x bar is x bar. dA came out to be y times dx. And divided by, and here again, it's going to be the same thing, 0, 1, and it's going to be y dx. All I did, I replaced dA with that, and same thing there. Now I'm going to go ahead and replace it. Y is equal to x squared, so instead of y, I'm going to put x squared. That's going to become x times x squared dx divided by y times, whoops, no y. Instead of y, we're going to say x squared dx. Okay, and then 0 to 1, 0 to 1. So now they become x times x squared become x cubed. If we integrate x cubed, become by 1 power higher, x4 divided by 4. This become x cubed And if I do that, that becomes x cubed divided by 3. Again, 0, 1, 0, 1. If I continue that right here, it's going to become basically 1 over 4 divided by 1 over 3. So that becomes 0.75 meter. So that's my x. Let's do the same thing for y. Okay, we're going to plug back in y bar. We said y bar is the same as y divided by 2. So that's y divided by 2. And dA, it's y times dx. Y times dx. And then divided by y times dx for dA. We're going to plug in. So y is equal x squared. So this becomes x squared divided by 2 times x squared and then dx. So x squared by x squared becomes x by power 4. To integrate it, this was x squared dx. So that comes out to, that becomes by x of 5 by power, x by power 5 divided by 10. And that's going to be x cubed divided by 3. And then we're going to do 0, 1, 0, 1. So that comes out to 1 over 10 divided by 1 over 3, which is equal 0.3. So our standard becomes 0.75 and 0.3. Was nothing to it. Okay, take a look at this problem. We want to find the area as defined. So they want the area basically on this right side. This is the area we're looking for. This whole right side, because they say between here and here. And one of the things I want to do on the first one where this vertex is. So I'm going to go ahead and just make a little line here, say x and y. And y is this equation. What if I make x is equal 0? If I make x equal 0, that become minus 2. And if I make y equal, so I'm going to say y is equal 5. If I make y is equal 5, that means 5 is equal 3x squared minus 2, or 3x squared is equal 7, or x squared is equal 7 divided by 3, and square root of 7 divided by 3 comes out to be 1.528. So the vertex is basically right here, 0 and 2. All right, now we can go ahead and continue to find that. So the area is equal dA, which is equal, and it's going to be from 0, the x limit one is going to be to 1.528. And dA become right here y dx, which is equal, and y is equal, our strip we have right here is a dx times y, which we know that. But y, we know y is at 5 right here. Therefore, it's going to be 5 equal 3x squared minus 2, bring everything over here, becomes 7 minus 3x squared. So that's why we have 7 right here, minus 3x squared dx. And it's going to be 0 to 1.528. And if you integrate that, that's going to come out to basically 7x minus 3 times x cubed divided by 3. And that's going to be 0 to 1.528. And if you plug that in, the area is going to come out to be 7.128. So here there's a confusion because that's the height of the vertical strip. That's the height. And this is how it's done. Now, you go ahead and do the next two problems. While I erase this board, we're going to continue. Okay, next one is we're gonna do a centroid of a compound area. This is a plane and there's a hole in here. So what you gotta do, divide them by the shapes that you can think make it easier. I'm gonna go ahead and put a line right here, make that one shape. And I'm gonna go ahead and just make a straight line right here, make that another shape. So now I got a square, square, triangle, and circle, which is easy. And we already have those dimensions right there. I'm gonna say this is gonna be 1. And let's make this 2. And make this 3 and make this 4. Then I'm going to go ahead and make a line up here. First I'm going to do shape number 1. The area of shape number 1 is A1 is equal, it's going to be 20 times 10, so that's 200. The y bar is going to be, everything going to be measured from right here, x, and also going up that way. Because this is a 20, so the center of it is going to be 10. So that's 10 times 200 is 2,000. Now the y bar is going to be halfway through here, and that's going to be 5. And 5 times 200 is going to be 1,000. So let's go to shape number 2. Shape number 2 is this, and the width of the shape number 2, area number 2 is 10 times 55. That's going to be 55 times 10, so that's going to be 550. I've got 550. And the x bar is going to be 20 plus another 5, it's going to be 25. 25 times 550, it's going to be 13,750. And the y bar is going to be halfway here, which would be 55 divided by 2, that'd be 27.5. And multiply these two numbers, it's going to come out to be 15,125. So shape 3 is a circle. A3 is equal. I said this circle is a 16-inch diameter, so it's pi r squared, which is pi times 8 squared. And if you calculate that, that should come out to 201.1, something like that. The x bar to the center of this comes out to 40. 40 times 201, it's minus 804, 2.4. Because minus, that's the whole, that's why. The y bar comes out to 35, and the total comes out to be 703.7.1. Check my math, but I think it's correct. Area number 4, it's a triangle, so area is equal 1/2 of 50 times 55, and that's 1375. The center is 1/3. So the center of this x is going to be xi for number 4. It's going to be 30 plus 1/3 of 50, right? 20, 50, yep. So that's going to become 46.67. These two numbers each other become, I think it's becoming 64,171.3. Y bar, it's going to be 67. See if you figure out how I got that. That's the same way that we calculate that. So those two multiply, it's going to come out to 5421. So I'll do summation of all of these here. This is going to come out to be summation 1,923.9, and this is going to come out to be 1,879, and that's going to come out to be 59,509. This is worth it. Once we do that, you can get an easy point out of this. And we know that y bar is equal summation of yi divided by yia divided by the summation of individual area, which we already have that. So that become 59,509 divided by 1923.9, and on a y section we're going to be 30.92. The x, it's going to be same way, summation of x I times a divided by the summation of all area, which is 71,879 divided by 1923.9, which gives us 3736. This is how you do a compound area. It might not be a bigger problem, take too long like this one, but if you time it, you can do this in 2 minutes. I mean, I explained it took me not too long. So you go ahead and do the next one while I erase the board. The next one we're going to go ahead, it's going to be moment inertia. You can find this equation on your handbook for a shape like this, which is made of different shapes. And first, before we do anything, we have to find out where the center of gravity or neutral axis of this is. We're doing the same thing as before, and we're going to go ahead and shouldn't take long, but mark my word for it. There'll be 1 or 2 questions like this on the exam, so you better learn it. First, I'm going to go ahead and break down to this shape. So I'm going to say, all right, shape 1, shape 2, shape 3. Shape 1 is basically, it's going to become 6 inch, and everything can be measured from here. And we're going to go up, so it's going to be, the center is going to be 0.5. That's going to become 3. Shape 2 is easy, 2 times, if that's a 14, that's a 12. So it'll be 12, 1 times 12 is 12. And the center of it's going to be 6 plus 1 is 7. And 7 times 12 is 84. The next shape is going to be 12, same thing. And from center here to here is basically 14, 13.5. You know that. And 13.5 times 12, it's going to be 162. Am I right? Of course I am. So that's going to come out to 24 and 630. And this is going to come out to 249. And we know from before that y bar is equal summation of ay divided by the summation of area. So it's going to be 249 divided by 30, that's 8.3. So our center is going to be right here, 8.3. Now we can go ahead and calculate d. The d is a distance, the center of each distance compared to the neutral axis or center of gravity. So where's this difference between this center and here? And we're going to go ahead and calculate those one by one. I'm going to say, okay, let me change color here. A1, I like D1. D1 is going to be basically 8.3 minus, it's going to be 8.3 minus 0.5. This is the center of this one. 0.5, so that's going to become 7.8. I'm going to put 7.8 here. D2, it's going to be the center of this shape, so 8.3 minus center of this shape is 7, I believe. 7, so that's 1.3, so this is a 1.3. And the next one is going to be D3, which is 13.5 all the way to here, minus 8.3. I have 5.2. Okay, area times d squared, I'm just going to figure those out. It's basically a calculation. 365, 20.3, is that right? Yeah. 324.5. The individual moment inertia of each one of these, it's going to be I is equal 112 BH cubed. And I'm just going to write it down and tell you how I got it later on. That comes out to 0.5. This one comes out to 144. And this one comes out to 1. Now, if I add all these up, it comes 145.5. This comes out to 709.8. I come back to that later. We can use a table, or we can just, instead of all this right here, we can go ahead and say, all right, Ix is equal. I'm going to use shape 1 first. Okay, 112. B is 6 inches. H is 1 by power 3 plus AD squared. Instead of AD squared, I already have it, which is 6 times 7.8 squared is 365. Okay, that's shape 1 plus shape 2 is right here, so it's going to be 112. B is 1 inch. H is 12 cubic plus AD squared, which is a 20.3. Plus shape number 3 is 112. B is 12. H is 1 cube plus AD squared is 324.5. And if you add all that up, see this number right here? That became 0.5. So if you do all of them, it comes out to 855. But if you have the table already done, so all you have to do is add these two numbers, comes out to 855. All right, I erase the board, you do the next problem. Okay, the next topic is covered in static is the friction. Take a look at this problem we have. We got this block, and question A and B, it says A, find the value of P to cause the motion to impede upward, and find the value of P to cause the motion going downward of the plane. So let's do A first. And before we do anything, we got to go ahead and do a free body diagram on this. And you know the normal force is going to be like this. We call that N. Because this is pushing up, the friction force is going to come up back this way. That's going to be F. And the weight is going to be vertical. It's going to come like that, and that's going to be kilogram. Be careful. You got to convert that to Newton. So it's basically 140 times 9.8, and that should come out to 1373 Newton. And everything is all set, so let's go ahead and we're going to use basically summation f of y is equal to 0. Because we're going to have this y as the axis, I'm going to say this is positive right this way. I'm going to have n, and then I'm going to have minus. This is a 30 degree, so this is basically saying from this right here, it's a 30 degree, if you translate it. So if I go ahead and get a vertical component, which would be this would be cosine of that. So minus 1373 cosine 30. So I got that, I got this. I think that's it. There's nothing else in there. Therefore, N is equal 1189 Newton. Now we know this equation given, F is equal static friction mu as time N. So that's the F, which is equal 1189 times mu is a 0.4. So that will give us 476 Newton. I'm going to go ahead and do summation f of x is equal, x is going this way. So I'm going to have P minus Newton F, which is 476. Then I have this one will be minus, because it's going to be coming out this way, so it's going to be 1373 sine of 30 degree equal. Zero, so P comes out to be 1163 Newton. So that was question A. Question B, it says, what if it's going downward? What is this going to be? So if it's going downward, that means this right here, if this thing is going downward, it's going to be going this way because it's coming down, so the friction is going to be this way, and that's the difference. We have everything else, so I'm going to go ahead and do summation f of x is equal 0 this way, and we're going to say P plus F, they're both going that way, minus 1373 sine 30, okay, equals 0. We know P came out to be, we don't know P. P plus F came out to be 476 minus 1373 sine 30 equal, and that's going to give us P is equal 211 Newton. All right, you do the next problem, and I hope you like this. Give it a thumbs up, and again, I love your feedback.